All right, balancing an equation. Let's take a look at this equation here and go through the process, go through the steps that are needed to balance this equation. First thing I would do is I would see what's out of balance. I'd go through and count atoms. I have one silver on the reactant side. I have one iodine on the reactant side. I have two sodiums, and I have one sulfur. Then I come over here to the product side and I would do them in the same order. I've got two silvers. I've got one iodine. I got one sodium. And I've got one sulfur. I try to do them in the same order so that my eyes don't play tricks on me and see things that aren't really there. When I look here, I want to look there. When I look here, I want to look there. I want to make sure that I'm looking in the same spot on each list because that's what my brain wants. That's what my brain needs to see. And I can see my silver's out of balance. I've got two on my product side, one on my reactant side. And my sodium's out of balance, two on the reactant side and one on the product side. I am allowed to put whole numbers in these blanks to fix that. I'm allowed to add coefficients to this equation to change the number of atoms of each of the elements. A coefficient is written in front of the chemical formula and it's multiplied through that chemical formula, changing every element in the formula. So when I look at this and I see one silver over here, two on the product side, I know I need to double this up. So I stick a 2 out in front of the silver iodide. That 2 changes both the silver and the iodine. It's 2 times 1 for 2 silvers and 2 times 1 for 2 iodines. My iodines were fine, but now they're out of balance. You know, that stuff happens. That's something that we just deal with, and we just keep on moving, we keep on chugging along, and we keep on trying to fix stuff. So I go over to the sodium. 2 on the reactant side, 1 on the product side. I know I need to double it up. So I stick a 2 out in front of the sodium iodide. And again, it multiplies all the way through that formula. 2 times 1 gives me 2 sodiums. 2 times 1 gives me 2 iodines. That little coefficient also fixed my iodine problems. My sulfurs were never an issue. When these two lists are the same, 2 silvers, 2 silvers, 2 sodiums, 2 sodiums, 2 iodines, 2 iodines, 1 sulfur, 1 sulfur. When those lists are the same, your equation is balanced and is following the law of conservation of matter. In chemistry, there are some shortcuts that can be applied to some of these equations, some things that we can do that you didn't do in physical science, and they regard these polyatomic ions that we have to deal with from time to time. When we deal with these polyatomic ions, we don't always have to break them down. We don't always have to list them as separate things. We can do this when we have the same polyatomic ion on both sides of the arrow, both on the reactant and the product side, and the elements that are in that polyatomic ion appear nowhere else. So my polyatomic ion is sulfate, and it's made of sulfur and oxygen. Well, there's no other sulfur and oxygen anywhere else. There's no other sulfur and oxygen anywhere else. So I really don't have to break this down. No parentheses means I have 1 sulfate. Over here it's 2 irons, 2 hydrogens, and when we have parentheses, we go with what's on the outside. So there's 3 sulfates over on the product side. So my iron's out of balance, my hydrogen's fine, my sulfate is out of balance. Now, as a tip, and I mentioned this the other day when I taught it, we don't want to start here, we don't want to start there. We don't want to start with the elements. We want to start with a compound. We can put something here to try to fix the sulfate, but there's no guarantee, or the iron, but there's no guarantee we're going to keep it. The best way to start is with a compound. And what I would do here is I'd see my sulfates are out of balance. I've got 1 sulfate on this side, I've got 3 over here on this side. So I need to triple up my sulfates by sticking a 3 in front of the hydrogen sulfate, the H2SO4. That's going to change both things. It's going to change my hydrogens to 6, 3 times 2, and it's going to change my sulfates to 3. Because remember, when there's no parentheses, you only have 1. It's like that. So it's 3 times 1 makes 3 sulfates there. So now I've taken care of the sulfates. I can start addressing my irons and my hydrogens. 1 on this side, 2 on this side. I can put a 2 there, and that will fix the irons. 6 hydrogens on this side, only 2 on this side, so I stuck a 3 there. 3 times 2 gives me 6. That fixes my hydrogens. So 2 irons, 3 sulfates, 3 sulfates, 6 hydrogens, 6 hydrogens. My lists are the same. That is a balanced equation, and I didn't have to break down my sulfate, my SO4. The last thing that I suppose I should mention are situations like this where you have one element in 2 different places. And that's very similar to when you see it in the chemical formula. I have 1 nitrogen over here, 3 hydrogens, and 2 oxygens. Over on the product side, same list: nitrogen, hydrogen, oxygen. And that oxygen only gets listed one time. I've got 1 nitrogen, I've got 2 hydrogens. When it comes time to dealing with my oxygen, I have to add these together. There's 1 oxygen here, there's 1 oxygen there, for a total of 2. Now, I've got 3 hydrogens on my reactant side, 2 on my product side. That's my out of balance element here. I have an odd number over here and an even number over here, and no matter what I do, I got to multiply by 2, so I'm always going to get an even number on the product side. So I'm going to start this reaction by making these hydrogens even. I do that by multiplying by 2. That will change my nitrogens, 2 times 1, and that will give me 6 hydrogens, 2 times 3. Now I can come back over to my product side, and the next thing that I would want to deal with here is what I just did to the hydrogens. I don't want to deal with the oxygen just yet because I've got this O2 over here on the reactant side. I kind of want to save that for last to make sure that I can fine-tune with that. So I'm going to go to the hydrogens next. 6 on the reactant side, 2 on the product side. I'm going to throw a 3 out there in front of the H2O to fix that. 3 times 2 gives me 6 hydrogens. For the oxygens, I still have to add. I've got 1 over here. I've got 3 times 1 over there for a total of 4. And again, you see what I just did there? I saved that O2 for last. I saved that element for last, so now I can come back and finish those oxygens out by getting 4 over here, fine-tuning that equation to get everything all balanced. Oh, wait a minute, didn't do it. Caught myself. I got 2 nitrogens over here and only 1 over here. So I'm going to have to add a 2 there to fix that nitrogen issue. Almost missed that. That gives me 2 nitrogens over there on my product side, but it also changes this. Now I got 5, and now I've got a little conundrum here. I've got 5 oxygens over here and no way to get 5 over there. This happens a lot in chemistry. When you get stuck like this and you can't figure out a way to get your odd numbers of oxygens over here, the quick and simple fix: double everything. Change that to a 4. So that's 4 nitrogens now, and 4 times 3 is 12 hydrogens. Change that to a 4. 4 times 1 gives me 4 nitrogens. 4 times 1 gives me 4 oxygens there, but don't total it yet, we have to add. And change that to a 6. 6 times 2 gives me 12 hydrogens, and then 6 times 1 is 6 on that side. 4 plus 6 is 10. So now we're up to 10. See, doubling that didn't throw anything else out of balance. Still 4 nitrogens, 12 hydrogens, 12 hydrogens. The nitrogens and hydrogens are still fine. Nothing's changed there. But what it's done is it's given us a balanceable amount of oxygens. We have 10 now. We have an even number now. And by sticking a 5 there in front of the oxygen, we can fix that. Very common kind of issue to have in chemistry there. If you ever get stuck and you've got an odd number of atoms on one side and you can't get the odd number on the other side, double everything. Just go through and double all the coefficients that you've already written in. That will give you an even number to work with, and it'll make it a balanceable problem. That was a very lucky, happy accident.